So in example 3 here, we're going to find the volume of a solid from rotating the region enclosed by y equal root x and y equal x. That's right here. So y equal root x is up here. And then y equal x right here. And we're going to rotate that about the line x equal 1. So instead of the x-axis or y-axis, we're going to rotate around another line. Go ahead and sketch that line. So that's the line x equal 1 right here. So let's go ahead and sketch our solid of revolution. So we rotate this around. I'm going to go ahead and do this in black. So we rotate that line y equal x around. We'll get something like that. Let me extend the axis here. And then if we rotate the y equal root x around, we're going to get something like this. And let's go ahead and draw the bottom on that rotated solid. And then we are going to slice it up into washers along that axis x equal 1, which is parallel to the y-axis. So we want to draw a typical washer here at height y. I'll go ahead and do that in green. So at height y, we are going to have an inner radius for our washer and an outer radius for our washer. They're going to touch on that line y equal x and y equal root x. So that washer is going to look like this on the inside. And then on the outside, it's going to have a thickness, dy. So that's going to be the height of that washer. And so our inner radius is right here. So that is our inner. And for a given y value, that radius is this distance here, which is the distance from the line x equal 1 down to this line here, which is x equal y, or y equal x. But since we're rotating around an x constant line and we're adding things up in the y direction, adding our washers up in the y direction, we're going to write the line as x equal y, and we want to write our radius in terms of y. So the right-hand side x-coordinate is 1, and the left-hand side is y. So this distance is going to be 1 minus y. And then our outer radius, let me move this out of the way. Our outer radius is right here. And the right-hand side right here at the line x equal 1, and the left-hand side is y equal root x, which is equivalent, if you square both sides, to y squared equals x. So if we take the difference of the two x coordinates here, that's going to give us the distance from the line x equal 1 out to x equal y squared. So this is going to be 1 minus y squared. So we could have done the radius here on the right also, but we don't know the equation of this line here and this curve here. So you want to determine your radius with the curves that you have the equations of. So from your axis of rotation to the curves that you have the equation. So then our volume here, we are integrating from a to b, pi times our radius squared times our height, which is dx. And for our radius here, we're going to do outer squared minus inner squared. So this will be integral pi, and then we're going to do outer radius squared. So our 1 minus y squared is our outer radius. That gets squared. Minus our inner radius squared, which is 1 minus y. So 1 minus y. That gets squared. Dx. So again, this is outer radius squared minus the inner radius squared. And we are going to add those washers up from 0 up to 1. So integral 0 to 1. And now we just need to multiply this out and do a power rule. So let's factor that pi out of the integral. So pi integral 0 to 1. And then 1 minus y squared squared. So that'll be 1 minus y squared times 1 minus y squared. So first term's 1. Outer term's negative y squared. Inner term's negative y squared. That's negative 2y squared. And then last term's y to the 4th. And then we're going to subtract off 1 minus y times 1 minus y. So first term's 1. Outer term's negative y, inner term's negative y, that's negative 2y. Last term's plus y squared. And then all of that we are integrating with respect to y. So dy. Okay, so let's go ahead and change our signs and add here. So we're going to be adding, and this will be negative 1, positive 2, negative y squared. So this will be integral pi out in front, 0 to 1. We've got 1 and then negative 1, so these will cancel. Let's see, we've got a y to the 4th, no other 4th power terms. So y to the 4th. Negative 2y squared and another negative y squared minus 3y squared. And then, let's see here, 2y plus 2y dy. So now we'll go ahead and do our antiderivative. So we got that pi out in front. Antiderivative of y to the 4th is y to the 5th divided by 5. You are raising the exponent, divide by the new exponent. Antiderivative of 3y squared is y cubed, right? So that's y cubed. And antiderivative of 2y is y squared. So that's plus y squared. We're evaluating from 0 to 1. So when you plug in 0, you just get 0. So all you have to do is plug in 1. So this is pi times 1/5 minus 1 cubed plus 1 squared. And then this is negative 1 and positive 1. They cancel. This is just 1/5 pi. So that's rotating around a line other than the x or y axis. So I am going to do one more example, and then I'll have you try web work problems 4 and 5.